Okay, this is going to be my second try for the kinetic energy experiment, which is going to be the same experiment as the one that Franklin Hu did. Now Franklin Hu, so this is, I'm going to drop an object with something that rolls from this ramp. The mistake that Franklin Hu did, he let it drop from twice the height instead of 4 times the height to make sure it's going to go 2 times the velocity. So I did this already, but I made a mistake. I made a mistake. So I was like, okay, so this is my object. It's just tape, but it's pretty round. Of course, it's not going to be perfectly round, and it's not perfectly smooth, but it kind of produces the same results. So I was like, okay, let's drop it from 5 centimeters. This is 5 centimeters. As you can see, 5 centimeters. And then I'm like, okay, 4 times the height, times 4, which is 20. There it is, 20. And then I drop it from here. But of course, that's not the height. I was like, God damn, I'm such an idiot. This is the height. So now I'm like, okay, let's see, let's start from 2 centimeters. Can you see that? No, let's try it. My camera work is not my best skill. So this is supposed to be 2 centimeters. Can you see that? No, it doesn't really focus. This is 2 centimeters high. So now times 4, we go to 8 centimeters high, which is actually a lot higher. Oh man, focus, come on. There it is. You see the 8? There's my line. This is 8 centimeters high. Okay, so that's the line. This is my ramp. This is the line of 2 centimeters high, and this is going to be all the way up here, the line of 8 centimeters high. So it's a lot more big difference than 5 centimeters over here and 20 over here. This is just measured from this side. I should have measured it, and I did, of course. It should be this side. This is the height, not this. So it's correct, right? So let's do it. Let's see what it gives. This is 2 centimeters high. Gotta make sure that, before I start, I gotta say that there are some technical difficulties. First of all, yes, my object is not perfectly round, it's not perfectly smooth. Second of all, the floor, it's made out of tiles, and I've checked with my water level here. I've checked the tiles, and not every tile is equally leveled. It's not equally leveled. So it's going to be a problem. It's going to go, it's going to go a little bit uphill and then a little bit downhill. It's going to change in velocity. There's going to be changes in velocity, and there are joints in the tiles, so that will have an effect on its direction and its velocity, and on eventually the energy, of course. And then this ramp, it's pretty thick, as you can see. So let me try. It will fall off as I let it go. Wait, it's not good. It falls off a little bit. So there will be a collision with the floor, so that will cause it to lose energy and stuff. So there are obviously technical issues. It's never going to be perfect. But let's see what it does anyway. So this is 2 centimeters high above the ground. So, and also as it falls, it kind of falls at the beginning of this tile. So we have to measure the tiles, really. That's all. Even though I put some tape on the ground, not really necessary. 2 centimeters high, which is almost, that's 2 1/4 of a tile. 2 tiles plus 1/4 of a tile. Again, now it's only 2 tiles. Again, you gotta do this a couple of times and then take the average. Yeah, almost, yeah. It was almost like 1/4. It's not going in a straight line, so this will be less. Okay, one more time. So kind of the same result. So I suppose it's like 2 1/4, 1/4 of a tile. So according to the kinetic energy formula, 4 times as high produces, oh shit, I'm wrong. No, it's correct. So 4 times as high, 4 times the energy, 2 times the velocities. It should go at least 8 tiles. Should be more. Between 8 and 10, at least 8. And according to the kinetic, to the momentum, it should be 4.5. And kinetic energy about 9. So this is 8 times as high, 8 centimeters high. 4 times as high, which is 8 centimeters high. All right, so it's 1. Wait till it. Ah, damn it. So there is a problem. Starting from this tile, the floor starts to go downhill a little bit. Just a little bit. It's not perfect, as you can see. So it goes a little bit downhill. So as it enters this tile, it will start to accelerate a little bit. So that's another technical issue. I didn't count, so let's do it again. Yeah, not a straight line. Stopped right there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 and a half. 10 and a half tiles. Should have been at least 8. Should have been, I guess, 9. It shouldn't have been going over 9 tiles. It's 10 and a half almost. So it's more than predicted, I guess. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It goes over 10. The same, 10 and 1/4. One more time. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 and a half. 10 and a half. Let's start from 2 centimeters high again. Gotta start in the middle. Now it's only 2. So actually, yeah, it's going further than the prediction. It's even going further than 4 times as far. So yeah, momentum-wise, it's a lot more. A lot more. So I don't know. These are the results with these basic tools. It's absolutely not ideal, the circumstances. But this is correct, right? the height 2 times high versus 8 centimeter high, just like that. This is the height. This is how I have to do it. This is the height. Instead of just measuring it like this, 5, 5, 5, 5. Just because, so 5 centimeter versus 20 centimeter, this is 4 times the distance, but that doesn't mean it's 4 times as high. This means it's 4 times as high. 2, and then 8 centimeters all the way up here. So okay, this is gonna be experiment number 1, and we'll do more, of course. And the video. Till the next time.